Good afternoon, everyone. So, in today's class, we will solve exercise 9.4 of differential equation. Okay. So, at first, we will recognize which method we should apply to solve given differential equation. Either it is a variable separable method or the method of homogeneous differential equation. So, the first question is solve x square plus xy dy is equal to x square plus y square dx. भाई बंद कर दो. हेलो. Okay. So at first write this equation into the standard form, that is dy by dx is equal to some function fxy. And then if you can separate the variable, then just apply the variable separable method. Or if you can't separate the variable, then we apply the procedure of homogeneous differential equation. And for that, the function fxy must be a homogeneous function of degree 0. Then the given differential equation is a homogeneous differential equation. Then we use the appropriate substitution for y so that my given differential equation become in such a form where we can apply the variable separable method. Okay. So at first you try. So the given differential equation is x square plus xy dy is equal to x square plus y square dx. So now we write this equation into more standard form, that is dy by dx is equal to x square plus y square by x square plus xy. Now just look this given differential equation. Can we separate this variable? Okay. So to solve a given differential equation, at first try to separate the variable, write the x terms with dx and the y, all the y terms with dy. And if you can't do this, then we see, is it the function fxy? So when we compare, we get fxy is equal to x square plus y square by x square plus xy. So now we check, is it the function fxy is a homogeneous function of degree 0? And for that, just replace x and y by lambda x and lambda y. So when we put lambda x and lambda y in place of x and y, we get lambda x square plus lambda y whole square by lambda x whole square plus lambda x into lambda y. That is x square plus y square by x square plus xy. And that is same as function fxy. So we get lambda to the power 0 into fxy. So the function fxy is a homogeneous function of degree 0, and thus the given differential equation is a homogeneous differential equation. And to solve it, we make a substitution as y equal to vx. And for that, we just differentiate y equal to vx to find the value of dy by dx. So when we differentiate it with respect to x, we get dy by dx is equal to v plus x into dv by dx. Okay. So to differentiate vx with respect to x, we apply the product rule of differentiation. So v into differentiation of x, that is 1, plus x into differentiation of v with respect to x. So we get v plus x into dv by dx. Now we have value of y and dy by dx. So we just substitute this value into the given differential equation, that is dy by dx is equal to x square plus y square by x square plus xy. So when we substitute, we get v plus x dv by dx is equal to x square, and in place of y, we just substitute vx. So we get vx whole square by x square plus x into vx. Now we can cancel out x square on the right hand side from the numerator and denominator. So we get v plus x dy by dx is equal to 1 plus v square by 1 plus v. So after substitution, when we substitute the value of dy by dx and y, now we try to separate the variable. Now we write in the form as v with dv and x, all the terms with x with dx. So for that, we get x dy dx is equal to 1 plus b square by 1 plus b minus v. We take the b from the left hand side to the right hand side. And now we just simplify the right hand side portion. So we get 1 plus v square minus v into 1 plus v by 1 plus v is equal to multiply v with 1 plus v. We get 1 plus v square minus v square by 1 plus v. So v square plus v square and minus v square, it cancel out. We only left with 1 minus v by 1 plus v. And in this equation, now we can separate the variable. So just write the term with v with dv. So we get 1 plus v by 1 minus v into dv is equal to dx by x. Okay. So second step is complete. Now we just integrate both sides to get the general solution of the differential equation. And to integrate this, now we apply the algebraic manipulation. So we write 1 as 2 minus 1 plus v by 1 minus v is equal to dx by x. And when we separate it, we get 2 by 1 minus v minus 1 dv is equal to dx by x. So now we can integrate this term easily. So integrating both sides, we get integration of 2 by 1 minus v minus 1 dv is equal to integration of dx by x. As we know, that is integration of dx by 1 minus x is minus log mod x. So just apply this formula. So integration of 2 by 1 minus v is minus 2 log 1 minus v, and integration of minus 1 dv is minus v, and integration of dx by x is log x minus the constant log k. So we get v is equal to minus 2 log 1 minus v minus log x plus log k. So now we apply the properties of logarithmic, that log m plus log n is log mn and log m minus log n is log m by n. So when we apply this both property on the above expression, we get v is equal to log k by x into 1 minus v whole square. As we can write 2 log 1 minus v as log 1 minus v whole square. And then we take minus sign common from log 1 minus v whole square minus log x. So we get log x into 1 minus v whole square. And when we apply the property on log k minus log x into 1 minus v whole square, we get log k by x into 1 minus v whole square. So to get the solution in the original variable x and y, substitute back the value of v as y by x in this equation. That is y by x is equal to log k by x into 1 minus y by x whole square. That is y by x is equal to log kx by x minus y whole square. Just simplify this terms in this bracket. So we get kx by x minus y whole square. Take the log on the left hand side, it becomes exponential. So we get e to the power y by x. Therefore, the required solution of the given differential equation is x minus y whole square is equal to kx e to the power minus y by x. Okay. So whenever we have to solve a given a differential equation, at first just clearly observe the given differential equation. If you can separate the variable, as we can write in the form like all the terms with y with dy and all the terms with x with dx, then just integrate both sides, we get the general solution. And if the given differential equation can't be separated in the form of the in two variables, then we apply the procedure of homogeneous differential equation, and for that the function fxy must be a homogeneous function with degree 0. Then we use appropriate substitution, either y is equal to vx, and when we substitute the value of dy by dx and y, our differential equation transform into a form where we can separate the variable, and after that just apply the procedure of separation of variable method. So we get the general solution of the given differential equation. Okay. Now question 2 is solve y dash is equal to x plus y by x. So our given differential equation is dy by dx is equal to x plus y by x. That is a first order and first degree differential equation. Okay. So to solve this differential equation, either we can apply the variable separable method, or if we can't separate, then we have to check, is it a function fxy is a homogeneous function of degree 0 or not. And if this function fxy is a homogeneous function of degree 0, then our differential equation is a homogeneous differential equation. Then we apply the procedure of homogeneous differential equation. Okay, so try. Okay, so given differential equation is y dash is equal to x plus y by x. So to solve this given differential equation, at first, in the first step, we have to prove this given differential equation is a homogeneous differential equation. And for that, we compare it with dy by dx is equal to fxy. Okay. And here fxy is x plus y by x. So when we write in the standard form, that is dy by dx is equal to x plus y by x, that is dy by x is equal to fxy. So fxy is x plus y by x. So now we have to prove the function fxy is a homogeneous function of degree 0. Because we know a given differential equation is a homogeneous differential equation if the function fxy is a homogeneous function of degree 0. Okay. And to prove a function is a homogeneous function, we replace x and y by lambda x and lambda y. So when we replace x and y by lambda x and lambda y respectively, we get lambda x plus lambda y by lambda x. Now, when we take lambda is common from numerator and denominator, so we get lambda x plus y by lambda x. Lambda cancel out. We only left with x plus y by x. And x plus y by x is a function fxy. So we get fxy. So we can write in the form lambda to the power 0 into fxy. As we know, lambda to the power 0 is 1. Okay. So my function fxy is a homogeneous function of degree 0. Thus, the given differential, it implies that the given differential equation is a homogeneous differential equation. Okay. First step is complete. In a second step, we use a substitution to solve this given differential equation. By using the substitution, we just transform this differential equation dy by dx is equal to x plus y by x in such a form where we can separate the variable. Okay. So to solve it, we make the substitution. And what is the substitution? We just take y is equal to v into x. Okay. So differentiating both sides of y is equal to vx with respect to x. Now, when we substitute y is equal to vx, that is, we converting our differential equation in the variable of v and x. So we have to write dy by dx in terms of v and x. So we have to find the value of dy by dx, and for that, we just differentiate this equation y is equal to vx with respect to x. And we know that whenever we have to differentiate product of two functions, that is d by dx is equal to u into v, so we apply the product rule, and that rule says that is at first v into du by dx, that is v multiplied by differentiation of u plus u into differentiation of v. So that when we have to differentiate y is equal to vx with respect to x, we get dy by dx, and for vx, we just take v, and dx by dx, that is 1 plus x, then differentiation of v, that is dy by dx. So now we have value of dy by dx, and we use the value of y, that is vx, and we transform our differential equation, that is dy by dx equal to x plus y by x, in terms of v and x. Okay, we just remove your variable y in terms of v. So we get v plus x dv by dx is equal to x plus vx by x. Okay, so we get v plus x dv by dx is equal to 1 plus v. X cancel out. From the numerator and denominator on the RHS part, so we left with 1 plus v, and there is v on the left hand side and also v in the right hand side. So this v is cancel out. So we only left with x dy by dx is equal to 1. Okay, so now we separate the variable. So we get dv is equal to dx by x. This is your step 2. Step 2 is complete. Now to find the general solution, we just integrating both sides. So on integrating both sides, that is integration of dv is equal to integration of dx by x. And we know that is integration of dx by x is log mod x. So we get integration of dv is v is equal to integration of dx by x, that is log mod x, plus that constant of integration, that is c. Then at the last step, we just put the original variable, that is y and x, in place of v. So for v, we take y is equal to vx. So v, the value of v is y by x. So substitute back the value of v in this solution. So we get y by x is equal to log mod x plus c. Therefore, the solution of the given differential equation is y is equal to x log mod x plus cx. Okay, that is the general solution. Why general solution? Because there is present a arbitrary constant. Now, question number 3 is solve x minus y dy minus x plus y dx is equal to 0. Okay, so follow all the steps. At first, write into the standard form, that is dy by dx is equal to some function fxy. Recognize the function fxy. Then prove that the function fxy is a homogeneous function of degree 0. Then our differential equation become homogeneous differential equation. Then use the substitution y is equal to vx. Okay, and then transform the differential equation into such a form where we can separate the variable and just integrate both sides to find the general solution. Clear? Okay, so try. Okay, so let's solve this question step by step. So the given differential equation is x minus y dy minus x plus y dx is equal to 0. So when we write into the standard form, it becomes dy by dx is equal to x plus y by x minus y. So when we compare it with the standard form, dy by dx is equal to function fxy. The value of fxy is x plus y by x minus y. Okay, and to prove this given differential equation is a homogeneous differential equation, we have to prove the function fxy is a homogeneous function of degree 0. And for that, we just replace x and y by lambda x and lambda y. So we get f lambda x comma lambda y. So just put in the place of x lambda x and for y lambda y. So we get lambda x plus lambda y by lambda x minus lambda y. When we take common lambda from the numerator and denominator, so lambda cancel out, we only left with x plus y by x minus y. That is your function fxy. So we can write in this form lambda the power 0 into fxy, and it implies that the function fxy is a homogeneous function of degree 0, and thus the given differential equation is a homogeneous differential equation. Okay, the first step is complete. We proved that the given differential equation is a homogeneous differential equation. So we can apply the procedure of homogeneous differential equation to solve the given differential equation. Okay, and for that, to solve this differential equation, we make the substitution, that is y is equal to vx. That means we are just expressing y in terms of x and new variable v. And this step is crucial because of this step, we simplify our differential equation where we can separate the variable. So, we're differentiating both sides of y is equal to vx with respect to x to find the value of dy by dx. That is dy by dx is equal to differentiation of vx with respect to x. And now we apply the product rule of differentiation. That is differentiation of uv with respect to x is v into differentiation of v. U with respect to x plus u into differentiation of v with respect to x. So we get dy by dx is equal to v plus x into dv by dx. So substitute the value of y is equal to vx and dy by dx is equal to v plus x dv by dx in the differential equation. And that differential equation is dy by dx is equal to x plus y by x minus y. So when we place the value of dy by dx and y, we get v plus x dv by dx is equal to x plus vx by x minus vx. So when we take x common from numerator and denominator, x cancel out, we only left with 1 plus v by 1 minus v. So my differential equation become, after substitution, x dy by dx is equal to 1 plus v minus 1 minus v minus v. Okay, so now we simplify our RHS part. So just do addition and subtraction. So we get 1 plus v minus v into 1 minus v by 1 minus v. We take the LCM, that is 1 minus v, and apply the, just add this. So we can rewrite this as x into dv by dx is equal to 1 plus v square by 1 minus v. Okay. So after simplifying the equation, it allows us to separate the variable. So we can rewrite this as, we just separate the variable. We write the terms with v with dv and the terms with x with dx. So we get 1 minus v by 1 plus v square dv is equal to dx by x. So now we have to integrate this, and for integration we just separate the terms. So at first we write 1 by 1 plus v square minus v by 1 plus v squared. dv is equal to dx by x. Integrating both sides, we get integration of 1 by 1 plus v square minus v by 1 plus v square dv is equal to dx by x. So we have to find integration of 1 by 1 plus v square minus integration of v by 1 plus v square dv is equal to integration of dx by x. And we have a formula for integration. That is, whenever we have to integrate, integration of f dash x by fx dx is equal to log mod fx plus c. And integration of dv by 1 plus v square is tan inverse v. So we just use this formula. For the first term, that is integration of dv by 1 plus v square is tan inverse v. And for the second term, we use this formula. So we get tan inverse v minus 1 by 2 log 1 plus v square is equal to log mod x plus c. So now substitute back the value of v, that is y by x. So we get tan inverse y by x minus 1 by 2 log mod 1 plus y by x whole square mod is equal to log mod x plus c. So when we simplify, we get tan inverse y by x minus 1 by 2 log x square plus y square by x square is equal to log mod x plus c. Now we apply the property of log. So we get tan inverse y by x minus 1 by 2 log mod x square plus y square minus log mod x square is equal to log mod x plus c. That we know that log a minus v is log a minus log v. So we just apply that property. And we also have the property of log, that log a the power n is n log a. So we can write log x square as 2 log x. And when we multiply with minus 1 by 2, we get plus log x. So log x is cancelled out from the left hand side and right hand side. So we only left with tan inverse y by x is equal to 1 by 2 log x square plus y square plus c. Okay, we remove the mod sign. Why? Because x square plus y square is always positive. Therefore, the solution of the given differential equation is tan inverse y by x is equal to 1 by 2 log x square plus y square plus c. Okay. Okay, so let's move to next question. So question number 4 is solve x square minus y square dx plus 2xy dy is equal to 0. So just apply all the step of solving a differential equation by homogeneous differential equation. Okay, so try. Okay, just let's solve together. So the given differential equation is x square minus y square dx plus 2xy dy is equal to 0. So we can write it as dy by dx is equal to minus x square minus y square by 2xy. Okay, so when we compare it with a form dy by dx is equal to fxy, the value of fxy is minus x square minus y square by 2xy. Okay. So to prove the given differential equation is a homogeneous differential equation, we check is it a function fxy is a homogeneous function of degree 0 or not. And for that, we replace x and y by lambda x and lambda y. So we get lambda x whole square minus lambda y whole square by 2 into lambda x into lambda y. That is minus x square minus y square by 2xy. As lambda is cancelled out. Because from the numerator there is a lambda square. And also in the denominator there is lambda square. So we get lambda the power 0 into fxy. And it implies that the given function fxy is a homogeneous function of degree 0. And thus, the given differential equation is a homogeneous differential equation. Okay. Now, to solve this differential equation, that is your homogeneous differential equation, we make the substitution as y is equal to vx. And then we differentiate both sides of y is equal to vx with respect to x. We get, apply this product rule, that is differentiation of uv with respect to x is v into differentiation of u with respect to x plus u into differentiation of v with respect to x. So we get dy by dx is equal to differentiation of vx, that is v, into differentiation of x, that is 1, plus x into differentiation of v with respect to x, that is dy by dx. So substituting the value of y and dy by dx in the equation, dy by dx is equal to minus x square minus y square by 2xy, we get v plus x dv by dx is equal to minus x square minus, in place of y we substitute vx, so vx whole square by 2x into vx. So we can rewrite this as v plus x dv by dx is equal to v square minus 1 2v. Now we have to separate the variable. So for that, we just simplify. So we get x into dv by dx is equal to v square minus 1 by 2v. And take v from the left hand side to the right hand side, we get minus v. And when we simplify it, we get v square minus 1 minus 2v square by 2v. That is x into dv by dx is equal to minus 1 plus v square by 2v. So 2v by 1 plus v square dv is equal to minus dx by x. That is your, we just separate the variables. We write all the terms v with dv and the terms with dx with dx. So now we can apply integration. So when we integrate in both sides, we get integration of 2v by 1 minus 1 plus v square dv is equal to minus dx by x. To integrate the LHS part, just see the denominator part. There is 1 plus v square, and when we differentiate 1 plus v square, we get 2v. So it is of the form integration of f dash x by fx dx. Okay. And we know that different integration of f dash x by fx dx is equal to log mod fx plus c, and different integration of dx by x is log mod x. So using this formula in this expression, we get log mod 1 plus v square, as here fx is 1 plus v square and f dash x is 2v. And for minus integration of dx by x, that is minus log mod x, plus that constant of integration we take it as log mod c. Why? Because then we can apply the property of log to simplify our solution. So we get log c by mod c by x. Just remove the log from the both sides. We get mod 1 by 1 plus v square is equal to mod c by x. Now substitute back the value of v, that is y by x. We get 1 plus y square by x square is equal to plus minus c by x. Therefore, the solution of the given differential equation is x square plus y square is equal to cx. We take the new arbitrary constant c, small c, for plus minus c. Okay. The solution is x square plus y square is equal to cx. Yes, you are right. Okay, so next question is solve x square dy by dx is equal to x square minus 2y square plus xy. Okay. So at first write into the standard form and then apply the procedure of homogeneous differential equation method. Okay, so try. Okay, so to solve this given differential equation, that is x square dy by dx is equal to x square minus 2y square plus xy, we write it into standard form, that is dy by dx is equal to x square minus 2y square plus xy by x square. So this is in the form dy by dx is equal to f xy, and here the value of f xy is x square minus 2y square plus xy by x square. Now we have to prove this function fxy. We have to check is it the function fxy is a homogeneous differential equation or not. Okay, and for that we just replace x and y by lambda x and lambda y. So we get lambda x whole square minus 2 lambda y whole square plus lambda x into lambda y. So we can take lambda square common, and from the denominator there is lambda x whole square. We can also take lambda square common. So we get x square minus 2y square plus xy by x square. When we cancel out lambda square from numerator and denominator, so that is the function fxy. So we can write in the form lambda to the power 0 into fxy. So the function fxy is a homogeneous function of degree 0, and thus the given differential equation is a homogeneous differential equation. In a second step, to solve this given differential equation, we just use a substitution, that is y is equal to vx. So differentiating both sides of y is equal to vx with respect to x, we get dy by dx is equal to v plus x dy by dx. we apply the product rule of differentiation. And now we substitute back the value of y and dy by dx in this equation. We get v plus x dy by dx is equal to x square minus 2. The value of y is vx, so we get vx whole square plus x into vx by x square. And from there, in the RHS part, we can take x square common in the numerator and denominator. So then we cancel out the x square. We only left with 1 minus 2v square plus v. And v is also cancelled out from the left hand side and right hand side. So we left with x dv by dx is equal to 1 minus 2v square. And now we separate the variable x and y, x and v. So we have dv by 1 minus 2v square is equal to dx by x. Now we have to integrate this, and for integration, we just do manipulation so that we can integrate easily. And for that, we take 1 by 2 common, we get 1 dv by 1 minus 2 minus v square. And here we can write 1 by 2 as 1 by root 2 whole square. We get 1 by 2 into dy 1 by root 2 whole square minus v square into dx by x. And now this is in a standard form. We have a formula for this special case on integration. So when we're integrating both sides, we get 1 by 2 integration of dy 1 by root 2 whole square minus v square is equal to integration of dx by x. As integration of dx by x is log mod x, and integration of 1 by a square minus x square is 1 by 2a log mod a plus x by a minus x. And to integrate the LHS part, we use this formula. Here the value of a is 1 by root 2 and the value of x is v. So just apply this formula. We get 1 by 2 into 1 by 2 into a, that is 1 by root 2 log 1 by root 2 plus v by 1 by root 2 minus v is equal to log mod x plus c. So when we simplify, we get 1 by 2 root 2 log 1 by root 2 plus y by x by 1 by root 2 minus y by x is equal to log mod x plus c. Therefore, when we simplify, the solution of the given differential equation is 1 by 2 root 2 log mod x plus root 2y by x minus root 2y is equal to log mod x plus c. That is your general solution. Now question number 6 is solve x dy minus y dx is equal to root under x square plus y square dx. Okay. So let's solve. We have given x dy minus y dx is equal to root under x square plus y square dx. Just take y dx from the left hand side to the right hand side. We get x dy is equal to y, we take dx as common, so we get y plus root under x square plus y square dx. And we write in the standard form, that is dy by dx is equal to some function. We get y plus root under x square plus y square by x. So this is in the form. So the value of fxy is y plus root under x square plus y square by x. And to prove this function fxy is a homogeneous function of degree 0, we just replace x and y by lambda x and lambda y. To get lambda x plus root under lambda x whole square plus lambda y whole square by lambda x. When we cancel out lambda, we get y plus root under x square plus y square by x. That is lambda to the power 0 into fxy. So the function fxy is a homogeneous function of degree 0. So the given differential equation is a homogeneous differential equation. So to solve it, we just make a substitution as y is equal to vx, and then we just differentiate it with respect to x to find the value of dy by dx, and that is dy by dx is equal to v plus x into dy by dx. Now substitute the value of y and dy by dx in this equation. We get v plus x dy by dx is equal to vx plus root under x square plus vx whole square by x. So we can take x common on the numerator and denominator, and when we cancel out, we left v plus x dy by dx is equal to v plus root under 1 plus v square. So we can rewrite this as dy root under 1 plus v square is equal to dx by x. And we know that integration of dx by root under 1 plus x square is log x plus root under 1 plus x square. So just use this formula. When we're integrating both sides, we get log mod v plus root under 1 plus v square is equal to log mod x plus log mod c. Now apply the property of log. So log mod m plus log mod n is equal to log mod mn. So we get and substitute back the value of v, that is y by x. So we get log y by x plus root under 1 plus y square by x square mod is equal to log mod cx. And when we cancel out log from the both sides, we get y plus root under x square plus y square by x is equal to mod cx. So when we remove the mod sign, we get y plus root under x square plus y square by x is equal to plus minus cx. Therefore, the solution of the given differential equation is y plus root under x square plus y square is equal to cx square, where c is plus minus c. Now, question number 7 is solve x cos y by x plus y sin y by x y dx is equal to y sin y by x minus x cos y by x x dy. Okay, so just let's solve. The given differential equation is this. So we can write it into standard form, that is dy by dx is equal to y by x, x cos y by x plus y sin y by x by y sin y by x minus x cos y by x. And this is in the form dy by dx. So fxy is this function. Now we have to prove that this is a homogeneous function of degree 0. And for that, we just replace x and y by lambda x and lambda y. So just put lambda y in place of y and x and lambda x. So we get lambda y by lambda x cos lambda y by lambda x plus lambda y sin lambda y by lambda x. And this. So we can cancel out lambda and lambda from numerator and denominator. We get y by x. And also in the bracket term, we can also cancel out this lambda. So we only left with we get lambda to the power 0 into fxy. So my given function fxy is a homogeneous function of degree 0. So the given differential equation is a homogeneous differential equation. Now to solve it, we make just a substitution, that is y is equal to vx. And we find the value of dy by dx, apply the product rule. So dy by dx is equal to v plus x into dv by dx. Substitute the value of y and dy by dx in the given differential equation. We get v plus x dy by dx is equal to x cos v plus vx sin v into vx by vx sin v minus vx cos v into x. So we can rewrite this as v plus x dy by dx is equal to v cos v plus v square sin v by v sin v minus cos v. So when we simplify it to separate the variable, we get x dy by dx is equal to v cos v plus v square sin v by v sin v minus cos v minus v. And when we simplify it, we get x dy by dx is equal to 2v cos v by v sin v minus cos v. After separating x and v term, we have v sin v minus cos v by v cos v dv is equal to 2 dx by x. So we get 10v minus 1 by v dv is equal to 2 dx by x. Now integrating both sides, as we know, the integration of 10v is log sec v and dx by x is log x. So just apply this property. We get log mod sec v minus log v is equal to 2 log x plus log mod c. Now apply the property of logarithmic. We get log mod sec v minus by v is equal to log cx square. Just remove the log and also the absolute sign, and we get sec v is equal to cx square v. And after we just substitute back the value of v, that is y by x. So we can rewrite this as sec y by x is equal to cxy So cos y by x is equal to 1 by cxy. That can be written as 1 by c into 1 by xy. So we can replace 1 by c with a new constant, that is k. So my general solution to the given differential equation is xy cos y by x is equal to k. Okay.